Welcome to Lecture 9 of CSE 4635. In this lecture, we will be continuing our session management discussion from our last lecture, and we will be discussing on URL rewriting and hidden form techniques of managing sessions. After that, we will move on to Servlet Filters and see how Servlet Filters work and what is their main purpose. So let's get started. In the last lecture, we saw how we can manage a session with cookie and HTTP session. We know that when we use the getSession method to create a new session, automatically a cookie is generated with the key name JSessionID, which stores the unique session ID that is used to identify that client between each request, right? Now, if for some reason the client has disabled his cookies on the client side, then what happens is that cookie will not be generated and we will not be able, or the server will not be able to identify that client for further requests. So for that reason, what we need some kind of alternative, right? And that alternative is provided by the technique of URL rewriting. The URL rewriting technique is actually pretty simple. Since we know that we cannot store client-side cookies to store the session ID, all we have to do is we have to somehow append that specific session ID to the client-side's request URL so that between each request, the client will always be sending that session ID as a parameter with his URL. All right. So to do this, it only requires one additional step, which is basically encoding the URL with the session ID, right? The good thing about servlet URL encoding like this is that it is a fallback approach that only kicks in if the client-side browser cookies are disabled, all right? We can encode URL with HTTP servlet response encode URL method, and whenever we encode, we use this method, what happens is the session ID that is generated by the getSession method is automatically appended to all of the client requests that will be coming from the client, all right? So by using this method, or by using either encode URL or encode redirect URL method, it is possible to encode the session ID with the client-side request URL in case cookies are disabled on the client side. So let's see a demonstration to see how this works. Okay, so for this demonstration, we will be using the same project that we used in our last lecture. That is, we will be using our session management lecture. Okay, so if you remember, in this project, we have a login page, which has two input fields, the username field and the password field. And this form action is defined as login servlet. That is, the information in this form is going to be passed on to our login servlet. All right. And the method has been defined as post, so we will have to override the doPost method inside our login servlet. So let's see what is happening inside our login servlet here. So inside the doPost method of our login servlet, what we have to do is at first we have to verify whether the user has entered the right credentials or not. So in this case, we have defined that we will only be accepting the username and password as Anas and Jawad respectively. So that is what we will be checking for here. Okay. So at first we acquired the username that the user has entered in the form, and we have also acquired the password that the user has entered inside that form. Next, we are checking if the username and password fields are correct or not, that is, whether they are Anas and Jawad respectively or not. And if the combination of username and password is correct, then we are entering this if condition. Now, inside this if condition, we are at first creating a session. So we know that whenever this getSession method is called, a new session will be returned if if a previous session does not exist. Okay, so that is what we're doing in this line. Next, what we're doing is we are adding an attribute to this session. Now we know that it is possible to add multiple attributes to a session by using a key and value pair, right? So that is what we are doing by using this session.set attribute method. And the name of the key we are setting as current user. As for the value of that key, the value of the key is the name of the currently logged in user, which is in this case Anas. All right. Cool. Next, what we did is we are creating a cookie as well. So we are trying to showcase the use of both HTTP session as well as HTTP cookie in this project. All right. So for that purpose, we will be creating a cookie as well. And after creating this cookie, inside this cookie, we will be setting the same username. We will be setting the same key value combination that we have entered in our session. So we will have a cookie with the key name as current user, and the value of that current user will be on us here as well. Okay. Next, what we did is we added that cookie to our response object. Now what we are going to do is we are going to encode the URL. That is, we are going to encode the client URL in case the client has disabled cookies on his browser. And for that, we only need to write one single line, which is this one here. So we know that if the client has successfully entered the right credentials, we want to redirect our client to our login successful page, right? Now, to redirect the client to our login successful page, at first, our server, that is our web application, will have to verify that the client has indeed entered the right credentials, right? So for that reason, we use a session ID. But in case the client has disabled cookies on his browser side, then there is no way of transferring that session ID from the client to the server, right? And so by using this encode URL method, what will happen is that session ID will be appended to the client's request URL, which will be passed on to the server, and the server can utilize that URL to identify that client. All right, so that's what we're doing here. By using this encode URL method, again, what we're doing is we are going to append the JSession ID, that is the unique session ID that is generated for that client by our getSession method, to the client's request URL. All right. So after we have encoded the URL, all we have to do is we have to redirect our client to that URL, right? So we are using response.sendRedirect method, and inside this method, we are passing the encoded URL that we have just generated here. All right. So now let's see what is happening inside our login successful page. That is what is happening after our client has successfully entered the right credentials. So here, as you can see, we are creating an HTTP session class, an HTTP session object again. And this time, when we call the getSession method, we will be returned our previously created session. All right. Next, what we did is we are creating a username and JSession ID string object. This variables will be used to essentially store the currently logged in username or the currently logged in user and the unique identifier or the unique session ID that has been generated for that user. So first we are checking if the session is indeed valid or not. So if the session is not valid, that is, if the session with the current user key is null, then we are redirecting our user to the login page here. All right. And if it is indeed valid, then what we are doing is we are storing the name of the currently logged in user under our username variable. Okay. Next, what we did is we have created a cookies array because it is possible that multiple cookies have been set up for our client. So we are using request.getCookies to get all the cookies that have been set up or that have been generated for our client. Next, we are iterating through all those cookies. And what we are doing is to get the value of the unique session identifier that has been generated for that client, we are checking which cookie has the name as JSessionID, because we know that whenever we use the getSession method, we automatically create a JSessionID cookie with the value as the unique identifier that will be used to identify that client, right? So first, we are checking if the cookie has the name JSessionID or not, and if it does have the name as JSessionID, then we are storing the value of that JSessionID under this JSessionID string variable. All right, all right. So far so good. Next, what we are doing is inside this login successful page, we are simply printing a message. We are printing welcome to the Thunderdome username, which is the name of the user that is currently logged in. And we are also going to show him the value of his session ID. That is the value of the unique identifier, which will be used to identify him. Finally, what we did is we have also created a form here, and this form will have a single button called log out, and this logout button is going to be used to log out the user from this session. That is, it will be used to invalidate his session. So now let's see, since the form action has been defined as logout servlet, let's see what is happening inside our logout servlet here. Now inside this logout servlet, you can see that we have again created a session object, and we are trying to get back our previous session by using the get session method. Similarly, we have also created a cookies array to get back all the cookies that have been generated for that specific client. Now, in our last video, I showed you that whenever you wish to manage your sessions by using only cookies, and you wish to log out a user, in case you are using cookies, you had to find the cookie that corresponds to that user, and then you had to invalidate that cookie by setting the timer to 0, right? But in a practical sense, what happens is multiple cookies can be set for a user, right? So for actually logging him out from all those sessions, what we have to do is we have to invalidate all those cookies. That is, we have to set the timer for all those cookies to 0. So that is what we are doing here. We are iterating through all the cookies for this client, and we are setting all their timers to 0. So basically, we are invalidating all the cookies that have been assigned for that particular client. Similarly, we will be invalidating the session that has been assigned for that user or that client as well. And the way we do that is simply by calling session.invalidate. All right. So after that, we can successfully say that the user has logged out, and we can then redirect him back to our login page. Now, the main takeaway from this whole demonstration is that our main work here is this encoding part here. All right, this encoding part is the main thing, or the main line of code that actually will be used whenever our cookies are disabled on the client side. So now let's run this code and see a basic presentation of how this encoding URL technique works. Okay. All right, so to test that our URL rewriting technique actually appends the JSession ID to the client's requested URL, what we are going to do is we are going to use a regular window of Edge browser as well as an incognito window of Edge browser. We know that in case of incognito windows, cookies are disabled, and so this is the perfect opportunity to test whether our web application appends that JSession ID to the client's URL or not in case of disabled cookies, right? Now, at first, let's try to access our web application through a regular window and see what we get. So if we try to log in, all right, we have been logged in successfully. We have this session ID as our current session ID. And as you can see in the client URL side, we do not have any JSession ID value appended to it, right? Now let's try to simulate the same thing inside an incognito mode. So if we go to our web application URL and try to log in, okay, so in this case, we have another session ID because this is a completely new session, which is separate from our regular session here. And in this case, if we look at the client URL, you will see that our JSession ID is appended to the client-side URL as a parameter, right? So since cookies are disabled on the client side here, that is on the incognito side here, what happens is this JSession ID is appended to the client URL, and this JSession ID is going to be used by the server to basically identify that client and restore a session for that client, which is stored on the server database. Okay, so this is how the URL rewriting technique works. Another technique which can be used to manage sessions in case of disabled cookies is called the hidden form field technique. So in this technique, what happens is hidden form fields or hidden fields are used to store the client state. Client information is stored in some hidden field, and that hidden field can be accessed by another servlet. Okay. So a big disadvantage to using this technique is that extra form submission is required on every page. Now that is a very big overhead that is not wanted. So I will not be showing any in-detail demonstration for this. Let's just show you, or let's just see a simple code sample to see how this hidden form field works. So at first, we are getting a value submitted in the form from an HTML file. So suppose we have a static login.html page, and we are getting some information like the user's name from that HTML form. All right. Now, what we want to do is we want to pass this user information, that is this name, that this username, from one servlet to another, but we cannot store it in the session because client-side cookies are disabled. So for that, what we are doing is we have created a form inside our page here, and this form is going to have a hidden input field. So as you can see, it has an input type is equal to hidden tag and the name and value as the currently logged in user. Now, when the user will hit submit on this form, automatically the information that is stored in this user string variable is going to be passed on to the next servlet. That is, it is going to be passed on to the second servlet. However, the client will not be able to see this value because the input type for this value is set to hidden, right? And so the client will not be able to see this information. Now, other than the big overhead disadvantage, another big disadvantage is that this kind of information can easily be inspected by using any modern browser, and it is possible to check any confidential information even if you use the hidden tag here. So this is not exactly a good method that you should be using whenever you are trying to manage sessions. Okay. Our next topic, and probably the last topic for servlet technology, is servlet filter. A filter is used to intercept a request before it reaches a resource. Essentially, servlet filters give you the opportunity to access your HTTP servlet request and response objects before they are passed on to other resources or other servlets. So essentially, a filter allows you to perform some kind of pre-processing to your requests before they are handled by any other resource. Filters have many uses. For example, they can be used to log the IP addresses of all the incoming client requests. They can be used for user authentication, user input validation, even things like data compression, image conversion, and so on. Just like servlets, filters need to be configured using the deployment descriptor, that is, through your web.xml file, or through annotations. Filters are registered by using the filter element inside your web.xml file. The servlets to which the filter should be applied are defined by the filter mapping element. So essentially, you will have to use the filter mapping element to define which servlets this filter should be applied to. So to understand the working mechanism behind a filter, suppose I have a client and I have a servlet container with a single servlet. Now this servlet could be some other resource as well, like some static file or some JSP page. Now imagine, according to this web application, I have defined that I will have 3 filters, and these 3 filters are mapped to this servlet of mine. Now, combinedly, I am calling these 3 filters the filter chain. All right. So the way this will work is whenever the client will send any request for this servlet, at first that request will have to pass on through these 3 filters, and after the filters have performed some kind of pre-processing on that request, only then the request will be redirected to the servlet. So the client will be sending a request which will be received by these filters. And after the filters have performed some kind of processing on it, the request will be redirected to the servlet. Now the servlet, after performing its own processing on the request, it will send back the response to the client. Now, if I have defined the project in a way that the response will have to pass on through this 3 servlets, through these 3 filters again, then the response will be again received by these filters. And according to my application's definitions or according to my application's logic, if the filter wants to perform any kind of processing on the response as well, it will perform those processing. And if not, the response will be directly forwarded to the client. All right, so that is the basic mechanism of how a filter works, or basically how a chain of filters work. Now let's take a look at the API that is used to write filters. There are 3 interfaces when it comes to writing a filter. We have filter, filter config, and filter chain. So now let's take a look at the filter interface first. The filter interface has 3 methods or 3 functions: the init method, the doFilter method, and the destroy method. Now this init method is basically the same as the init method of the servlet interface. That is, it is used to initialize the lifecycle of the filter. Now inside this init method, you can see that we have passed a filter config object as parameter. This filter config object can be used to access the configuration of the filter that has been defined in our deployment descriptor that is in our web.xml file. Next, we have the doFilter function of the doFilter method. Now, this method is the main method which is responsible for performing the actual filtering. This method is called every time a client requests for a resource to which the filter is mapped. That is, if we have mapped this filter to any specific servlet, and if any client has requested for that servlet, at first this method will be called, and then the control of the resource or the control of the request will be passed on to the actual servlet. So inside this doFilter method as well, you can see that we have three parameters: the request object, the response object, and a filter chain object. Now, since we have access to the request and response objects inside this method, then it means that we can perform any kind of processing on that request response pair, and then we can pass them to the actual servlet. As for the filter chain object, we use this filter chain object to pass control to the next filter, or if there is no other filter that needs to be performed on that servlet, we simply pass the control to the next servlet, that is to the actual servlet. Finally, we have the destroy method, and this destroy method is basically the same as the destroy method of the servlet interface. That is, it is used to close our filter and close any resources that we have used for running this filter. Okay. Next, we have the filter config interface. The filter config interface has four methods. The getFilterName method is used to return the name of the filter. The getServletContext method is used to return the servletContext object. Next, we have getInitParameterNames method, and this method is used to return an enumeration object which contains all the parameter names that I have defined or that the developer has defined for the filter. Finally, we have the getInitParameter method, which is used to get the value for all the individual parameters that have been defined for this filter. All right. Lastly, we have the filter chain interface. Now, there may be multiple filters that can be applied to a resource. So according to the last diagram that we saw to understand how filters work, we saw that there were three filters that have been applied to a specific resource, that is to a specific servlet. Now, we call this a chain of filters, or simply filter chain. The filter chain interface is used to keep track of all the filters that need to be applied to a resource. This filter chain interface has only a single method, and the method is called doFilter. This method is invoked whenever we want to pass the control to the next filter in our chain, or this method is called whenever there is no other filter that need to be applied to a resource and the control needs to be passed on to the actual servlet. Now, do not confuse this doFilter method with the doFilter method of the filter interface. If you notice carefully, this doFilter method has only two parameters, the request object and the response object. However, in case of the filter interface's doFilter method, we had three parameters: the request object, the response object, and the filter chain object. Now, this doFilter method is invoked on that filter chain object of the filter interface's doFilter method. Okay, so don't worry about the specifics for now. When we will see a demonstration on this, it will become much more clearer. And finally, if we do not call this method, then the whole program flow will stop. So be sure that you do call the doFilter method of the filter chain interface whenever you wish to pass the control from one filter to another or from one filter to the actual resource. Now let's take a look at what the deployment descriptor or the web.xml file looks like whenever we want to define or register some filters for our project. So in this web.xml file, you can see that we have two servlets, filtered servlet and filtered servlet 2. Next, we have the mappings for the servlets, but that is not important. What we are interested in is this filter element here. Now, as you can see, this filter element has two nested elements, filter name and filter class. Filter name and filter class elements are used to basically register a filter. The name of the filter that we are trying to register is given as basic filter, and the class that this basic filter is referring to is also basic filter class. Okay. Next, we have to map which servlet this filter should be mapped to, right? So to define that, we use the filter mapping element. Inside the filter mapping element, we have two other elements, filter name and servlet name. Now inside the filter name tag, we will write down the name of the filter which we are mapping, and inside the servlet name element, we write the name of the servlet to which this filter needs to be mapped. So for this example, we have stated that the name of the filter is basic filter, and the servlet to which we are mapping this basic filter is filtered servlet. Now, it is possible that we want to use the same filter for multiple servlets, right? In that case, all we have to do is we simply have to create another filter mapping element. And inside this filter mapping element, we need to define the name of the filter and the name of the servlet again. So in this case, we had another servlet, as you can remember, filtered servlet 2. So we are mapping the basic filter to the filtered servlet 2 servlet as well. All right, so that's what we are doing in this web.xml file. So to recap, in this sample web.xml file, we have two servlets, filtered servlet and filtered servlet 2. We have defined a filter called basic filter, and we are mapping this basic filter to both of our servlets. That is, we are mapping this basic filter to both filtered servlet and filtered servlet 2. Now, if you remember, we mentioned that it is possible to define initial parameters for a filter through the web.xml file, that is, through our deployment descriptor. We have also mentioned that the filter config interface can be used to access those parameters. So let's see how that works. So this is a sample web.xml file again, and inside this web.xml file, you can see we have registered a filter called basic filter. Now, whenever we are registering a filter like this under the filter element, we can define another element called init param element. Now, this init param element can be used to define any number of parameters that we want to define for that specific filter. So in this case, we are using a single pair of the init param element to define this parameter called devName, and we are defining the value of devName as Anas Jawad. Similarly, we are defining another initial parameter through this init param element again. And in this case, the name of the parameter is devPhone, and the value of the parameter is 01234, so on. So in this way, as you can see, we can use this init param element as many times as we want inside the filter element to define any number of initial parameters for that filter. All right. Now, if you're wondering how to get the values of, or how to get the names of these parameters from this web.xml file, that is pretty simple as well. Inside the doFilter method of our filter interface, we simply have to write filter config.getInit parameter, and inside this function, we need to pass the name of the parameter for whose value we are trying to extract. So in this case, again, what we are doing is we are using the getInit parameter method of the filter config interface to get the value of the initial parameter devName. So as you can see, since we are using devName as the parameter here, we will be getting the value Anas Jawad. And in this case, since we are using devPhone as the parameter name, we will get the value 01234567889. So that is how you can define any number of parameters inside your web.xml file, and how you can access those values inside your doFilter method by using the filter config interface's getInit parameter method. Okay. All right, so for this demonstration, we will be working on a project called Servlet Filter Demo. Okay, so this is the web.xml file for this project. Inside the web.xml file, I have registered two servlets, filtered servlet and filtered servlet 2, and I have defined the URL mapping for these two servlets as well. I have also defined that the filtered servlet is going to be the first page that the client sees whenever he or she enters our web application. Next, what we did is we have created a filter called basic filter, and we have defined that this basic filter refers to the basic filter class. All right, so some other things we did is we defined two initial parameters for this basic filter. We have defined a parameter called devName with the value Anas Jawad, and we have also defined another parameter called devPhone with the value 01234567889. Okay, next what we did is we mapped this filter to our two servlets. our filtered servlet, and our filtered servlet 2. Okay, so we are essentially using the same syntaxes that we just saw right now. Okay, now it might be possible that we have a requirement that says that this filter needs to be applied to any kind of client request. That is, whatever resource that the client tries to access on our web application, be it any servlet or any static resource, then we want that request to be filtered by our basic filter servlet. In such cases, what we can do is we can create another filter mapping element. We will name the filter name as basic filter because we want to apply this filter to all our requests. And instead of using servlet name, we will be using URL pattern. And inside this URL pattern, we can simply write /star. So what this will do is whichever kind of request a client makes to our web application, that request will at first be filtered by our basic filter, and then it will be redirected to whichever resource that the client has requested. Okay, but for now we do not need this because we are only going to show how this filter works for our two servlets, filtered servlet and filtered servlet 2. Also, instead of using /star, if we want to mention any specific URL pattern to which this filter should be applied, we can define that here as well. So for example, we can do something like this. So any URL pattern which matches the pattern /test, that URL pattern or that request will automatically be redirected first to this basic filter, and then it will be redirected to the actual resource that the client has requested. Okay. So let's take a look at our filtered servlet first. Now inside this filtered servlet, as you can see, we are not really doing anything. We are simply printing a simple message like checking things out in the first servlet. And after that, what we are doing is we are using a request dispatcher object to include the information in our second servlet, that is inside our filtered servlet 2. So let's see what is happening inside filtered servlet 2. Now inside our filter servlet 2 as well, as you can see, we are not exactly doing anything. We are simply printing a message that says checking things out in the second servlet. So the gist of the matter is we're not really doing anything inside our two servlets. What we are going to do is everything mentioned inside our basic filter. So let's see what we're doing here. Now at first, let's see how we can create a filter on IntelliJ. You simply right click on Java, hit new, scroll down to the bottom, and you will see we have an option called Create New Filter. Now, if you click on this option, you have the option to name your filter to whatever you want. And then if you want to use annotations to basically define configuration for your filter, then you can do that. Or if you want to use the web.xml file to define configuration for the filter, just like we did, you uncheck this box. All right, then you hit OK. So we created this basic filter by using the same process. And whenever you create a filter by using what I just showed right now, you will automatically see that this filter, that the filter that you have created is implementing the filter interface. Okay. And as you remember, the filter interface has three main methods: the init method, the destroy method, and the doFilter method. Now inside the init method, we are initializing the filter config object for this filter. Okay, so we are basically initializing the lifecycle of our filter. Next, we simply printed something in our console to basically keep track of the fact that we have called our init parameter once, or init method once. Okay. Now, inside the destroy method, we are nullifying the filter config object that we have for this filter. So basically, we are destroying the lifecycle of this filter, and then we have simply again printed a line on our console that says that our basic filter has been destroyed. Now our main task is happening inside this doFilter method. Now this doFilter method has three parameters, as you can remember: the servlet request object, response object, and a filter chain object. Now inside our doFilter method, we are at first printing something on our console that says that we have entered our basic filters doFilter method. And then what we are doing is we are getting the initial parameter values that we have defined in our web.xml file for this filter, right? So we have defined two string variables, dev name and dev phone. And inside this dev name and dev phone variables, we are basically storing the values of the dev name and dev phone parameters that we have defined inside our web.xml file. And to do that, we have used the filter config objects get init parameter method. Okay. And then what we did is we are simply printing the information that the name of the dev is whatever we have given inside our web.xml file, and the value of the phone number is, again, whatever we have given inside our web.xml file. So this line will be printed on our system console as well. So now, for a very basic demonstration, what we want to do is we want to log the client's IP address. That is, we want to log the IP address of the client which has requested our servlets. So for that, what we can do is first we are creating a servlet context object, and we are initializing that servlet context object with our filter configs get servlet context method. Okay. Then what we are doing is we are using the log method of our servlet context object to essentially write down the information about our client's IP address inside our containers log file. Now, as for the location of the log file, it is dependent on the installation directory of your web container. Okay. So to get the client's IP address, we can simply write request.get remote host, and this will return the IP address of the client. All right. And finally, we are printing the client's IP address on our system console. All right. So far, so good. Now, if you remember, after performing your do filter operation, you need to pass the control of the request to the next filter in your chain. So for that purpose, we need to use our filter chain objects do filter method. And if you remember, this do filter method has only two parameters, request and response. So we are essentially passing our request and response object to the next filter in our chain. Now, if we do not have any other filter in our chain, then what happens is this chain.doFilter method will pass the control of this request and response pair to the actual resource that has been requested by the client. Okay, so that is what is happening here. Now, for our basic application, since we do not have any other filter other than this basic filter in our filter chain, so the control of this request response pair will be handed over to the servlet which has been requested by the client. That is, in this case, it will be filtered servlet. Okay, so now let's run this application and see what we get. All right, so our web application has been deployed to our Tomcat web container. Now, if you look at the bottom left corner of the screen here, you will see that our basic filter initialized message has been printed on our system console. It means that our filter has been successfully initialized after our deployment. Okay, so now if we go to our web applications URL, you can see that the first line that we are seeing here is checking things out in the first servlet. That is, it is showing that our request has been passed on to the first servlet. And since our first servlet used a request dispatcher object to pass the control to the second servlet, that is to our filtered servlet 2, we have got that second line printed here as well. But the important thing, or the interesting thing to note here, is inside this console here. So if you remember, we had printed a couple of information inside our filter to be printed on our system console, right? So this basic filters do filter message is being printed because the do filter method of our filter has been called, right? Next, we can see that we are seeing the dev name as Anas Jawad and dev phone number as 0123456789. Now, if you remember, these are the values that we had defined inside our web.xml file as initial parameters for our filter, right? And finally, we are seeing that the client IP address has also been printed since we have printed that information inside our filter as well. Now, another thing to note here is that if you look on the right side here again, you will see that both of the servlets are being called, right? Now, inside our web.xml file, we had defined our filter to be mapped to both our filtered servlet and filtered servlet 2. By that logic, this three information should have been printed twice. But instead, what we can see here is that they have been printed only once, right? So why exactly is that? Well, the answer is actually pretty simple. You see, the client has only requested access for the first servlet. He has not requested access for the second servlet. The second servlet is being called by the first servlet. It is not being called by the client. Okay? So a filter will only be applied whenever a client asks for the resource. In this case, since the client has only asked for the first servlet, and so the filter has been applied only once. All right? If the first servlet is calling second servlet or some other servlet to which this filter has been applied, then the filter will not be applied in this case because the client himself is not calling for that servlet. Okay? Since that other servlet is being called by the first servlet, so the filter is not being invoked. On the other hand, if we were to access that second filter by ourselves by writing something like the URL for the web application and then filtered servlet 2, which is the URL pattern for our second servlet. Now, if you look at the console here, you can see that the information has been printed. Okay, so from this, we understand that whenever a client requests for a resource, if any filter has been mapped to that resource, only then the filter will be invoked. If that resource has been if that resource has been called by some other filter, by some other servlet that has already been invoked by the client, then the filter will not be invoked. Okay. A few closing remarks on filters. Filters are important for a number of reasons. First, they provide the ability to encapsulate recurring tasks in reusable units. So basically, if you have a specific set of lines of code that you need to apply before every filter or before every servlet, then you can simply write a filter for it and apply that filter on your servlets. Second, filters can be used to transform the response from a servlet or a JSP page. So basically what that means is sometimes it is needed for the web container or the server to return the response to the client in a specific format. So filters can be used to convert that response in that specific format. Filters are also used to validate form information. For example, a client may enter extra white spaces when entering his name in a form. A filter can be used to trim those white spaces. So you can write a filter to trim those white spaces and then pass that information to the actual servlet. But you can't really edit the form data directly. So in that case, what you have to do is you will have to get the wrong input from the form, trim the white spaces, and add that attribute to the request object by using your request object's setAttribute method. Finally, when this request is passed on to another resource, you can again use request object's getAttribute method to get the corrected value of the form data. All right. So essentially, filters can be used to perform different kinds of functions like authentication, logging, image conversion, data compression, encryption, and so on. Sky is really the limit when it comes to filters. So that is it for this lecture. If you have any question, then you can let me know in our live class. I will see you then. So take care and stay safe.